Okay, so welcome to today's video. Today's video, we're going to do a quick review on how to find the inverse and then how to graph the inverses and how to prove that they are inverses. So we're going to start with just some reminders of a couple of things. One is we are talking about finding the inverse of a function. So let's review again what the definition of a function is. In order to be a function, every x can only have one y. Okay, every x can only have one y. And the way we tested it, especially when graphing, is we did the vertical line test. And as long as it passed the vertical line test, it was a function. If we had a table or a mapping or a listing, we just double checked to make sure the x didn't repeat, okay? When we're looking at a graph, just a quick reminder that if you have a line, okay, it is a function, hence that's why we study it. So you've got an oblique line is a function. If you had a horizontal line, it would be a function. The only line that is not a function is the vertical line itself. And so yes, this would be a function. One, because if I run a vertical line test on it, it passes, okay? If we have, which is what we're looking at now, a quadratic, okay? A quadratic is also a function because, again, if I draw a vertical line, I'm not going to hit in two spots. The other one that we look at is if I have a absolute value, because that's another one that we have looked at, an absolute value graphs to be a V. And so if, again, I draw the vertical line, I'm only going to hit in one spot. What is not a function, so these are all yeses. And again, pretty much everything that we talk about in here is a function. One of the things that is not a function is a circle. Okay, a circle is not a function. Also, an ellipse would not be a function because when I go to draw my vertical line test, as you can see, I hit in two spots. And so this one is a no. Okay, and of course we've given you just some random graphs that are not necessarily one specific function. Maybe it's a piecewise that is not a function also. But for the most part, our general function, well, all of the general functions that we do are functions except for the circle. Okay, so our next thing that we're going to talk about then is how do we find the inverse? Okay, so there was a set of steps that we went through when we went to find the inverse. Okay, and I'm going to list those steps for you. So the first one is we always changed the f of x to y. Okay, the second step that we did is we switched the x and the y. Now remember, we only switched the letters, the x and y letters, no numbers, nothing like that. Number 3 is then we're going to solve for y. Number 4, we are going to, again, change, started right switch, we're going to change that y to the f inverse of x, okay? So those are our steps that we do to find the inverse. Okay, so I'm going to give you an example real quick. So if I have f of x equals 2x minus 3, and I'm going to run through these steps. So again, my first step is to take f of x and change it to y. My next step is to switch the x and the y. Okay. My next step is to solve for y. So in that case, I'm going to add the 3. Divide by the 2. Okay. And then our final step is to change the y to f inverse of x. And so I usually be sure I switch it and put the f inverse on the left. And you can either leave your equation in that form, or if you would like, you can put it into slope-intercept form so that we can graph it. So we have our inverse and we have our original equation, okay? So the next thing that we're going to do is we are going to check to make sure they are inverses by graphing. So the set of steps that we use if we're graphing, okay? Step 1, okay? We want to graph the original equation. Okay? Step 2, we want to graph, and it is dotted, the y equals x line. And again, because the original and the inverse are reflections over the y equals x line. Number 3, we are going to graph the inverse. Okay, and then just look by observation to see that they are in fact reflections. Now, another thing with that reflections is if your original point, again, is xy, whatever original point you have, remember the inverse's point is yx. So an example is if this one has the point 1, 3, this one would be 3, 1. Okay, that's an example. Okay, so let's actually graph then what we have here. And let's see if that works. So we're going to graph what we just did. So I'm going to start with the original, y equals, or f of x equals, or y equals 2x minus 3, which means my y-intercept is a negative 3, and I have a slope of 2. Okay, so I'm going to get me quite a few points there, and then I'm going to try to draw it as straight as I can. Mine's a little off, but get the point. Okay, the next thing that I'm going to do is I am going to dot in the y equals x line. So the y equals x line, again, is exactly what it says, y equals x. So it'd be 0, 0, 1, 1, 2, 2, 3, 3, so forth. Okay? And then the next thing that I'm going to do is I am going to graph the inverse. So it has a y-intercept of 1.5, and it has a slope of 1/2. Up 1, right 2, up 1, right 2, up 1, right 2. And then I am going to draw it in. That's a really bad line. But anyway, if you look at those two, they should look like, and again, mine is off, so if I was a little better at my drawing maybe, let's see if I can make that look a little bit better on there. Well, no, it didn't. Okay, but anyway, those should look like reflections. Both those lines actually look kind of curved. And what I mean by that is if you actually do a perpendicular line to these, they should be exactly the same distance. Now, the other thing that I told you is that the points are reflection points on there. So let's say I have the point here. Let's just do, well, we'll do this one here, which was negative 1. And so over here, I should have, if this is 1, negative 1, this one at negative 1, whoops, wow, I don't know where that came from. Negative 1, 1 would be the reflected point. And so we do have that right there. Okay? That would be another way of finding it. The other would be like 0. Here is 0, negative 3. So if I come over here to negative 3, 0, that should be a point. So it does look like it is the reflection. Okay? So that is checking the graph or checking inverses by graphing. Okay? Third thing that we did is we can also prove by composite of functions. And what composite of functions means is composite is when we put or substitute one equation into the other. And the composite symbol, again, is that little bitty O. And so the way we write it is if I do F composite F inverse of X, that will give me the letter X, okay, the variable X. If I do it the other way around, and you do have to check it both ways. Now, in your case, hopefully it would always work. If it works one way, it'll work the other. But sometimes that if you're just given two random equations and the question is to prove that they are inverses of each other, then you would have to double check both for sure. Okay, so we are going to do both of these checks. So again, I'm going to write my two equations. So this was my original, and my inverse was, what was that? 1/2 x plus 3/2. Okay, so those are my two equations. So the first thing that I'm going to do is F composite F inverse of x, and you do have to be sure you put those in the correct order. So what this is telling you is you're going to take your F inverse and put it into your F, okay? So I'm going to take my F inverse and I'm going to put it into my F. So just a substitution. So I have 2, and then I'm going to put my F inverse in, and then minus 3, okay? So there's my 2x minus 3. And then I'm just going to distribute and simplify. So 2 distributed through would be x plus 3 and then minus 3, which is x. So that checks. Okay? Now, my next one I'm going to do is just the inverse of it, if you want to call it that. I'm going to do F inverse of F of x. So that's now saying that I need to take, okay, the f of x and put it into the inverse. So now I'm taking my f of x, okay, and I'm going to put it here. Okay, so here we go. So I have 1/2 2x minus 3, oops, should have been a plus 3/2. Okay, distribute. So x minus 3/2 plus 3/2 equals x, and it does check. So again, just doing it a different way, I have now proved that those are inverses. So back up to what we've talked about. There's review of how you find, well, first, review of what a function is, how to find the inverse, how to prove their inverses by graphing, and how to prove their inverses by composite of functions. Okay? So we're going to do another video, and this one is actually finding the inverse now of a quadratic.